So picking back up on this one, we're looking for perfect cube roots. We're probably a little more familiar with those compared to fourth roots. This would be 125 times 2. This one would be a 27 times 2. The cube root of 125 is 5. So this one simplifies to the 5 cube root 2. Subtract. This one here had a perfect cube root 27, which is the perfect cube for 3. So we have 3 cube root of 2 left over. So after we simplify the various radicands, we do end up with a scenario where we're able to add and subtract our coefficients because they both have the cube root of 2. So now all we have to do is 5 subtract 3 to get the 2 cube root of 2. All right. Nice. So then there would be the final answer on that one. All right. Now, the next section is going to switch it up here a little bit. To an extent, we'll still see some of the same components, but it's going to have us start multiplying binomial expressions. And you might recognize this as foiling from the previous chapters, and that's all it's going to be, except now there'll be some square roots in there. Situations like this come up when you're working on engineering. Engineering has a ton of square roots come into play because when you do the distance formula to find the distance between 2 points, you are often left over with the square root answer because the square root is a part of that formula. And then if you find a side length to a particular room is this length and the other side length is this length, and you wanted to find the area of the room, you'd be multiplying those two side lengths together. So it's just kind of getting you ready for scenarios of when you would be multiplying two binomials together, and there's a square root in one. All right. Now it works just like foiling. So we have 3 times 1 is 3. 3 times square root of 5 is 3 square root of 5. Just like 3 times x would be 3x. Then we'd get square root of 5 times 1 to get another square root of 5. And then here, square root of 5 times square root of 5. I'm going to make a little side note up here. This is a throwback to last section because we're multiplying. Square root of 5 times square root of 5 would give us square root of 25, which just simplifies down to a regular old 5. We do have some like terms to gather here. We have some constants, so 3 plus 5 would give us 8. All right, and then we can also add up the 3 square root of 5 and the 1 square root of 5 to give us a 4 square root of 5. So that would be the final answer for that one after you FOIL it out. And then these are just, for the most part, easy points if you have basic understanding of the FOIL process and then combining your like terms. These don't really have any type of critical thinking. You just multiply the problems and work it out here. So let's go ahead and take a look at this one here. All right, so we do the FOIL process. 3 times 2 gets us a 6. Then we have a negative 3 square root of 6. Here we'll get a negative because there's a negative in front of the square root. Negative 2 square root of 6. And then on this last one, the green term, I've got negative square root of 6 multiplied by negative square root of 6. The negatives would cancel out, giving us positive. Square root of 6 times square root of 6 would be square root of 36, giving us a positive 6 there. And a shortcut on that is anytime a square root multiplies by itself, it always just becomes that term. We saw that when we were rationalizing. 6 plus 6 is 12. And then here, they have the same index, the same radicands. So we'd have subtract 5 square root of 6. All right, so once again, those are just foiling out, gathering up your like terms. And after you do multiples of those, you'll feel pretty comfortable with that.